Hey there, this is Mr. Wilford, and I wanted to go over Chapter 5, Section 7 with you, and this is a very important section here. Uh, this is all about the Pythagorean theorem, and we've talked about this a little bit already earlier this year, and I'm sure you've probably heard of it before. Basically, it's a great relationship between the sides of a triangle, of a right triangle, where we have our two legs, leg side A and side B are the legs. That forms the right triangle. And then we have the hypotenuse C. And the relationship, the Pythagorean theorem here is a squared plus b squared equals c squared. So it involves squaring this side and squaring that side, adding those together, and that's going to equal the hypotenuse squared. And this is used in many different places, construction, different buildings and things like that use Pythagorean theorem quite a bit. There's a Pythagorean theorem proof here that you can read through. That's kind of cool. It's kind of interesting how different areas talk about the Pythagorean theorem. Here's a nice couple of examples here of some nice kind of algebra examples here where you're figuring out and solving for the variable x. Notice again we're using the Pythagorean theorem a squared plus b squared equals c squared in each example, and then we're solving for the variable x. Again, it's nice if you can put this in radical form. That's typically the way that your book does it, but I actually prefer if you the decimal form. So if you have a good calculator and you can take 2 times the square root of 13, you'll get a decimal answer, and that will make a little bit more sense as far as talking about some of these sides. So yeah, you'll have some examples there where you're using the Pythagorean theorem. Of course, with the Pythagorean theorem, there's all sorts of application problems that you can look at, a ladder going up against a wall and things like that. You can read through here. There's a little bit of something called here the Pythagorean triple. Basically, it makes the numbers really nice for us here. So like a 3, 4, 5 is a Pythagorean triple. If you take and you let the legs of a triangle be 3 and 4, you'll get out the hypotenuse will be 5. In the same way, if you let one leg be 5, another leg of the triangle be 12, then your hypotenuse will be 13, and so on. So these are just some nice numbers. They don't come out as these weird kind of radicals and fractions and decimals and things like that. Take a look at a few more examples here. These are a couple of examples where, again, you're using the Pythagorean theorem. We use that quite a bit, so you want to make sure that you understand what's going on there with that Pythagorean theorem formula. We also talk about the converse of the Pythagorean theorem, and basically this is just saying that if you can show that a squared plus b squared is equal to c squared, then you can conclude that that triangle is a right triangle. Typically when you talk about the Pythagorean theorem, you're always starting out with you have a right triangle and then you can use the Pythagorean theorem. This is just saying if you know this equation here is true, then that would conclude that we would have a right triangle from that. So that's the converse of the Pythagorean theorem. And then we have a Pythagorean inequality theorems. And again, this is just using the formula but with some inequalities. If the hypotenuse squared is greater than the sum of the legs squared, you're going to have an obtuse triangle, so this is going to be greater than 90 degrees. If the hypotenuse squared is less than the sum of the legs squared, then we're going to have an acute triangle, so this is going to be less than 90 degrees. A couple other little things to look at here. Again, if you have any questions with any of this, please let me know. Again, the Pythagorean theorem is a very important formula for you to understand, so make sure if you do have any questions, you let me know. Thanks.